Let us find the reactions for this cantilever beam. So you already know the definition of cantilever beam. A beam which is having one end fixed and the other end free. It is called as cantilever beam. So let us find the reactions manually. Then verify the answers by using SAP 2000 program. So total length of the beam is 4 meter. And again it is having uniformly distributed load and point load. So point load 10 kilonewton, it is acting at the free end. Okay, so this is the problem statement. So let us have a free body diagram. So total length of the beam is 4 meter. So this fixed end is A and this free end, we'll call this as B. Okay, so for a fixed support there will be a three reactions. One is vertical reaction VA, horizontal reaction HA, and there will be a moment MA. Total length of the beam is 4 meters. Clear? Next, it is carrying a point load of 10 kilonewton at free end. So this will be 2 meter. So convert this uniformly distributed load to point load. So intensity of UDL is 10 kilonewton per meter. So multiplied by, it is acting over a distance of 2 meter. So here meter get cancelled. So 10 into 2, it will be 20 kilonewton. So this point load will be 20 kilonewton. Okay. So this will be 1 meter and this will be 1 meter. So first apply the equilibrium conditions, sigma h equals 0. So no horizontal forces, or else you can write HA equals 0. So this HA equals 0. So next apply the second condition, sigma V equals 0. So vertical forces are VA minus 20 kilonewton minus 10 kilonewton equals 0. So this is 20 kilonewton and this is 10. So therefore VA equals, you will get 30 kilonewton. So this VA as 30 kilonewton. Next apply the conditions, sigma MA equals 0. So here you have a movement MA which is rotating in anti-clockwise direction. So minus MA. So this 20 kilonewton, it will rotate in clockwise direction 20 into 1. So clockwise movement plus 20 into 1. Next this 10 kilonewton, it will also rotate in clockwise direction. So it will be 10 into 4. So equals 0. So minus MA plus 20 plus 40 equals 0. So your final answer will be MA equals 60 kilonewton meters. So this is a moment. So reactions are, so one is HA equals 0. So another one is vertical reaction VA. So it is 30 kilonewton. And moment MA equals 60 kilonewton meters. So these are the final answers. Okay, support reactions. So let us find the reactions by using SAP 2000 program. So once you open the program, first click on File, New Model. So once this window is opened, first select units. So then select beam. So number of span 1. So here length of the beam is 4 meter. So total length, see here. So total length of the beam, it is 2 plus 2, 4 meters. Okay. So remove the restraints. So please uncheck this box. Okay. So close this 3D view. So remove the grid lines for better understanding. So you know the definition. One end of the beam is fixed, the other end should be free. So select this joint, assign, joint, restraint. Here you should select this one, fixed. So apply, close. Next you need to apply the load. See here, one is point load 10 kilonewton at the free end. So select this joint, assign. So select this one, joint loads, force. So in which direction? So it is in Z direction. So minus 10. See here you can see the load 10 kilonewton point load. Next select this beam, assign. So in this case choose frame loads, distributed. See here. So this is your starting point. So select absolute distance from end 1. So this is your starting point of the UDL. So here absolute distance will be 0. So if you see end point of the load is 2 meter. So it is starting at this point and ending at this point, 2 meters. So absolute distance will be 2. So but for loads, see here, when the location is 0, intensity is 10. When the location is 2, intensity is also 10. So loads 10 kilonewton per meter, 10 kilonewton per meter. Apply, close. See here. This is the uniformly distributed load. So you need to neglect the self weight of the beam. For that, for which select the beam, go to assign, frame, property modifier. So weight, so you should use 0, apply, close. So then run the analysis only for dead load. Save the file by giving appropriate name. See here. So then display forces, joints. See here. Here the vertical reaction is 30 kilonewton. Close this. See here, moment. So it is 60. So now it is clearly visible. So vertical reaction is 30 and the reaction due to moment, it is 60. Clear. So this way you can verify your manual answers by using SAP 2000 program. Otherwise you can View the same answers in tabular form. Display, show tables, joint output, reactions, joint reactions. Okay. See here. Here the vertical reaction is 30, whereas movement is minus 60. So observe the units carefully. For vertical reaction, so unit is kilonewton. For movement, the unit is kilonewton meters. So practice the similar type of problems.